now we should be live. Let's just order these windows, wait for a couple. I'm sorry for the inconvenience, or the notifications, or whatever. Let's wait for. Okay, we have no dropped frames. We're streaming, but for some reason YouTube doesn't want to show me the viewer count. Why is YouTube doing this? Okay, I think YouTube is somehow bugged, but okay, so we can start. So today, let's repeat some things because of issues. Today we are going to solve problems in C, rather in C++, but I am going to compile them in C++ though. Because I haven't really set up a C compiler, and I don't really want to set up a C compiler. Okay. Let's see. Okay. We have a couple of different topics to start with, because these are, from a beginner's standpoint, very good topics. We have an array, a list of problems which use only like an array of elements. Also, this is somewhat similar. This may be somewhat similar list. Then we have digits in numbers, and we can actually talk about this a little bit more. Also, we can access any of we can find what I have been told is, for many beginners they're given problems with digits, so with some like digit calculation, some like shit like that. Okay, so we are going to find some digit problems. Maybe if I can search here, is it possible? Classifications, beginners. So yes, product of digits, number of sentences. Okay, we can take a look at some of the problems. Let's see. So let's start with digits and numbers. So the first thing you learn is how to input a number and then calculate something with its digits. So let's divisibility by digits. Let's see if these problems are hard enough. 4-digit number is given, determine whether it is divisible by each of its digits. It's a okay problem. A square of maximum. What is square of maximum? 3-digit number is given. Rearrange its digits so that to get the maximum number written with the same digits, then this maximum number should be squared and printed. A 3-digit number. Okay. Now this this is supposed to be solved with a conditional statement, which hints on that because it's a 3-digit number, you are given a fixed number of digits. So when you're given a fixed number of digits, this can be solved with only conditional statements. So only if and else. And because because we want to rearrange the digits to so that the maximum number written with the same digits. So what you want to do here is just take the 3 digits and have if statements such that you're sorting the digits by like top to bottom, and then you are recreating the number back, because the biggest number will always have the biggest digit on the front. So if you take this example, this number is probably, square root of this number is probably 732, and we're going to see that the square root of this number is 732. What does this mean? It means that the biggest digit is always on the biggest position, and then you're doing this, you're on the smaller digit. But of course these problems are very easy, because like even if it's not 3-digit number, even if it's n-digit number, this problem will be easy. But here they want you to solve it with the conditional statement, and I'm kind of bored. I mean, of course solving some problems with conditional statements is fine, but of course you can use arrays to make this a lot more elegant. Now I don't know if maybe should we solve this, or should we find some like harder problems? Please, 2 equal digits. We will solve one with conditional statement, then we won't solve anything with conditional statements. We'll solve with 4 cycles and something like that. So like really start from the beginning and then go through. So this will have a lot of conditions in order to sort these 3 digits. So find like the biggest of them, then like the digit in the middle, then the smallest digit. Okay, so this is kind of like, you can do this with swapping. So you can find the biggest and the second biggest like that with swapping, then regenerate the number. It will like take more time solving with conditional statements than just writing a general solution. But should we do it? Okay, like chat, should we solve this, or go to like, if you get how to solve it, we don't solve it, because like it's too easy and there's too many ifs. I want a solution with like, I want some problems that doesn't require that many ifs. 2 digits in a row. So this 2 digits in a row like sounds really good. 4-digit number is given. Determine is there 2 consecutive digits 3 and 7. Now, like we can like we can solve it with our okay, I can yeah, we can solve it with arrays. Although the sort function, I don't know if you will be given to like, if you can really use with the sort function, or you need to write your own sorting algorithm, which is a little bit off, like a little bit on the top here. We're just starting out, but rearrange digits, yeah. So we can quickly, I mean, I want the problem to be here so anyone joining in can see the problem. So I have this extension here which parses the problem. It takes the sample cases and like it puts them here, and then you want this to work really. So instead of doing this, we are going to do the old-fashioned way with stdio, and we're going to do it with n digits. We're not going to do it with 3 digits, we're going to do it with n digits. I mean, not with n digits, we're going to do it with at most 9 digits, because integers can be at most 10 digits. Excuse me. It's 10 to the 9. What is at most? So I forget that we are using this. So to get first we have like n digits, right? And then there is an interesting thing. If we don't use arrays, we can sort the number in place. But should we do this? Should we sort the number? There is a technique where you can sort, like where each digit you can sort the number each in place, so you can swap digits in place. But this is too, I mean, it's too difficult. Like for today, it doesn't really matter. So let's make an array where we're gonna call it digits and have like 10 digits, right? Let's go over the number. And here is another thing which I saw in many beginners. I saw this, that they are declaring all of their variables up there in the function, in the head of the function, which is a very old way of doing things. Why? Because the compiler will take this variable and declare it itself up there. But if you have like up there like 100 variables here, it's not that really efficient of keeping track of which variables you need right now and which you don't need, right? Which you need maybe later in the code. So whenever you need a variable, just declare it there. Don't have like like 300 variables at the top of the functions. You don't really need that. The compiler will take care of that. Okay. So we find that with modulo, we find the last digit, the digit of n, right? We want to put it into this array because we know like n will have at most 10 digits. For our problem, n will have 3 digits. I mean, for what this problem states, but we're going to say that n can have 10 digits, just for the fun, right? Now, how do you keep track of where are you in how many digits have you used? How many? So because C doesn't have a dynamic arrays, maybe this is like a little bit too loud. Okay, because C doesn't have dynamic arrays, what you need to keep track, you need some pointer to keep track. Let's call it count, okay, or pointer. A pointer doesn't need to be an object which points to some other object, right? A pointer can be only an integer which points to the last element of the array, or the element which is like so we are going to point to the element later than the last. So one element to the left, to the right of the last element. Why is this? This is always done because when you have like when you have this array which is length of 10, you don't know how many digits are you going to have, right? That's that essentially is the count of digits, right? Right? Essentially is the count of digits. Now we have 0 digit. We found one of the digits, right? And then digits at count of digits, and we're going to plus the count on the next iteration. So this is very very commonly done. So we say the digits at this count of digits is equal to digit and then plus. Okay. Now we have now we can just divide n. Now we have the digits of n in reverse order, right? Now we want to sort them, right? So how do we sort the digits? And plus, one more very important thing to learn. When you declare this array first has some garbage elements inside. Like, these are garbage elements, which are left over from memories which the operating system used for some other process. So these garbage elements do not tell you anything, right? But what you want is to have some kind of element which will tell you that in that position the array doesn't have anything. Like, this position is empty. So the best practice to do is either to memset the array, but memset is not defined in C. I need to enter some stupid library. I don't recall what kind of I don't really recall what was memset in C. What kind of library wanted. It should be. Why is that declared? Oh, why am I using std though? Okay, okay, not important. We can just run over the array and just I do this all the time. I do this. Run over the array and set it to -1. It's as efficient as memset. So you don't need to really, everything that a library can do, you can do it. It should be that in your mind. Everything that a library can do, you can do it. Okay. Now we set up to -1s. So we'll take a look. Do we need to set it up to -1s or do we need to something else later when we come to that part? Okay, so now we want to sort the digits, right? There is a sorting function, which if you include algorithm, there is a sort function which takes the pointer to the first element, digits, and then it takes a pointer to the element which is like to the size of that digit, so like to the last element you want to sort. We'll delete this. Sort is undefined because what? I don't know really see well, but unfortunately when you so you can use like qsort. What is q? What like you can use qsort, which is quick sort, and then you need to append this library or something, as I understand. And qsort requires that, but I will sort now the elements by myself. Okay, it's really that easy. I won't use any of the compiled functions. Now this is not good if you have like tons of elements. this will definitely be not good. Okay. Now I will have like, I can start at I plus 1, and now I want like if digits at I is bigger than, so I want to sort them in a decreasing order, right? So if digits at I is smaller than digits at j, I want to swap them. Now you tell me, is the swap function doesn't, why? Why? Because the compiler thinks it's C++ or what? Wait. No, the swap function exists in C as far as I know. No, exists in C++. What about in C? No, it was not declared in the scope. Okay. So we can swap the digits the old way around. Digits in J. Okay. So we sorted the array. Now we want to reconstruct the array into a number. So in order to reconstruct the array into a number, what we can just do is have some kind of number. Let's say this will be our result, right? Now we are going to go over the array, and I'm going, if you need to like yeah, that's what bubble sort. I don't know what is this. I mean, it's a quadratic sort. I don't know if like, I really don't know the bad sorting algorithms. Bubble sort was, yeah, insertion sort was that with the insertions. Bubble sort was with the swaps, probably, right? Right. Okay. Yeah. Okay. So we're going just to reconstruct the number. If the digits at I is not -1, what we checked before, if the digits at I is not -1, yeah, exactly. You got the function wrong. What is the function wrong? The qsort function? The qsort function, I have no idea how it works. Like, never programmed in C. Like, this is my first time. I mean, I don't know what I need. I have to like add like this library, and then the q function, the qsort has some other things which you need to add. But I'm just comparing the next element. If I will find like the biggest element here, which like is, and I will swap them. YouTube is saying something is wrong with the stream. Can you tell me at which line do you think am I wrong? Temp is digit I is this, I'm overriding this, and then I'm okay, we'll see. If digit is not -1, then what I want is I want the result to be first like +10 times 10, so everything is shifted to the left, right? And then I want to add on to the digit of I, and then I want only to see out the square of that. Line 19, if digit of I, so if the current digit is smaller than if like I find a digit which is bigger than that, I wanted it to be first. Oh, I don't know, like the algorithm may be like more efficient than what I'm doing, but I think this should work as well. Oh, I'm here's another issue. We have to print the result in C, actually. Oh, we have to print the result times result. So this test case is passed. So j+1, it's swapping. Yeah, it's swapping somehow like adjacent numbers, or what, the bubble sort algorithm. But I'm not swapping adjacent numbers. I'm finding the biggest number which is on the right, and I'm putting it here. And then I'm going to the next number, and then I'm finding the biggest number and putting it on the place there. So yeah, you can implement it anyway, like square root, n squared sorting algorithms. There are plenty, but what I recommend is using the actually built-in sorting algorithms when you're on competitive programming. But of course, if you can't use the built-in algorithms, or like me on C where I don't know quicksort, then it's a quick, handy way when you need to sort a small number of digits, a small number of elements. Okay, so we found the digits, we sorted them out, we regenerated the number, and then we made this like the result or something. We can also try on like some other worst case scenario. Okay, for me it works. And then always try when you're doing this either on competitive programming or as some kind of exam. Always try the smallest possible number. So either that is 1, either that is 2, doesn't matter. Like the smallest possible thing. Then we just submit the solution. We're going to submit it in C to see if that works. Okay. How do I submit? Okay, it passes. Okay. Now we're going to go on to more like harder problems. Okay. What is this? Divisibility by digits. Divisible by each of its digits. So one of the problems in C is that you don't have a Boolean. You don't have like when you write bool, there isn't a bool defined in C, but you need to include the std bool or something like that. I forgot what was for including for Boolean. Std bool. Although you are, well, you're given all the documentation. std bool, yeah, I was correct. Why is not given this std bool pkh? Oh, it is given. Okay. In many problems, you will need to import. You will need boolean, and this is no different. But let's see if I can find a problem which is a little bit. Delete one digit. This sounds good. All digit. Where was this when you had the consecutive? This was consecutive digits. 4-digit number is given. Determine whether is there 2 consecutive digits, 3 and 7. Okay. So we can do this and not just like 4-digit number. We can try an exercise where the digit number is bigger. So not to use a conditional statement. Okay, this is important. If you want to practice all of these problems, you have them and in the eOlymp. I will post this here as a contest for digits. Maybe we want to do some more interesting 2 digits in a row. This was 2 digits in a row problem. Yes, okay. All digits are even, all at least one odd. Yeah, okay. 4-digit. Okay, let's solve this one, and then we're going to go on a better stuff. Let's solve it really quickly, so we don't have we don't waste a lot of time on this. stdio. Then we have some number. Then I always forget that we're doing this in C. Okay, so how do you, so give me like the chat, which are beginners, give me like some ideas what like you might think. First of all, I want you to think about what happens in an edge case. So here the number we're given is a 4-digit number, but if the number is 1 digit, you have to think about what will happen if if like you're given some integer. It doesn't mean that it's 4-digit. You will always have to think about the edge case. What if the number is 1 digit? Well, now we don't have to think. We can just skip that. Okay, determine if there are 2 consecutive digits, 3 and 7. So what we can do is we can only have a boolean, which is going to be the answer. Always, if the answer is in boolean form, have a boolean. So the answer we're going to put is first 0 is false, because we assume that there are no consecutive 3s and consecutive 7s, right? And we can immediately, what I do is immediately I check for the answer. If, I mean, here will be the code, right? But I immediately check, and if the answer is yeah, if it's yes, or printf no. Now you can do this fancier in one line, and you can do it like, doesn't matter right now. Just do it your own way. Okay. When the digit is bigger than 0, now here's the thing: the digit has to be actually bigger than 9. The n we're having, because if it's like in 1 digit, it doesn't make sense, right? We're just going to skip that case. So one of the digit is n modulo 10, and the other digit, let's just do this, the other digit is n divided by 10 modulo 10, right? This is the other digit there. So we only check if they're both equal, and if this digit is, so if this digit is equal to 7 or this digit is equal to 3. We only have to check that. If that's the case, we say that we set the answer to true and we break. And this is, and we forget to divide by 10. Let's rerun them. Error while compiling. What's error while compiling? Okay, it says no. There could be 3 and 7. Aha, okay. Is there two consecutive digits, 3 and 7? Aha, okay. So I didn't actually understand that. Okay, I thought that either it's 3 threes, it's 2 3s or 2 7s consecutive. So, okay. So this digit has to be 7 and this digit has to be 3. Okay, so this digit is going to be the leftmost, the left digit, and this is going to be the right digit. And this is pretty much it. I'm just going to submit it. And I didn't understand the problem. I mean, I thought the problem was asking for different. Okay, accepted. Let's go something a little bit harder, because these digits are, I think, easy problems. I really think they're easy. Let's go to arrays, because arrays are always fun. It doesn't matter how, like, arrays can have like really easy problems and extremely hard problems. Let's start with something easy. To get the hang of the arrays, maybe we want to first do some like, let's see, what first do we want to do. Let's do this, neighbors of the same sign. This looks kind of interesting. I mean, neighbors, always in arrays, the neighbors are very commonly used. So like two numbers when they're adjacent, it's commonly called adjacent numbers, not neighbors, but whatever. This is more concise. Array n is given. Print the pairs of adjacent elements of the same sign. If there are no adjacent elements of the same sign, print nothing. Excellent problem. The first line contains n. The next line contains an integer. All numbers do not exceed 100 by the absolute value. This is sometimes important in some problems, because you can have inputs which are longs, and you need to know that actually you're accepting a long instead of an integer. Okay. So what we see here, that the array, the numbers are printed in consecutive order. Okay. So we're printing them in consecutive order, and now you want to ask what happens in this case. So it's printed like this and like this. Okay, you see that? Let's solve this problem really quickly. Let's just copy. I mean, we don't need this. Just need this. Scanf. Also, one more thing for people which are not who think like C++ is much better. Yes, it's much better, but the input output in this is a little bit off the topic. It's not about the problem, but so like if you have like huge problems, huge inputs and huge outputs, it's often recommended to use the scanf and the printf functions, although they are not, let me say it, they're not safe functions, so you have to be careful about them. But you will want to use them in some problems because they are much faster than cin and cout. You might be surprised because like I had a problem which did not was not accepted because of the use of C in and C out, because this was so slow. The problem had some like million digits in the input, million, not digits, million numbers in the input, and it wasn't accepted because of the use of C in. And scanf is much faster. Then when I figured out that like it was failing on input output time, then just change that to scanf and it works. So even if you are in C++, you can use scanf and printf when you have huge inputs. And you don't need to input that tested the IO. Include IO stream has scanf and printf included in itself. So that's a bonus trick from me. So use scanf and printf on huge inputs. Okay, we scanf the number. Always when you're given an array, you're going to be given some like n, the size of the array, right? Then what I do is I iterate over n, and now we have to create some kind of an empty array, right? So we see that we are not given actually how big the array is, but we are going to assume that 10,000 is going to be. Should we assume 10,000 or should we assume 50 or 100,000? It doesn't matter. Let's assume 100,000. It will pass either way. Maybe it's 100. All numbers do not exceed 100. Maybe n also do not exceed 100. It doesn't really matter. Let me just. Okay. So an array. How do you call this array? Doesn't matter. A. I call it A. Also, one more trick here. If you don't want to like write with like a lot of zeros a number, you can either do 10 to the power of like 5. This is 100,000. This here. So it's 1 times 10 to the power of 5. But now it's saying that it doesn't, it's a double, right? So you have to convert that to an integer here. But another thing is you can use these quotation marks to have the zeros, to know how many zeros are in packages. So this is like a million, right? But what we want is only this number, so 100,000. So this is a little bit more like you can see how many zeros you have, a little bit cleaner. Okay. We are going to scan all of the numbers inside. And if there are neighbors, many times what you want to do is this. You want to start from 0 and end at n minus 1. I mean, not n minus 1, but n minus 2 actually. Because the last number you don't want to count. Because the last number is neighbor of the previous last number, but there has no neighbors on the right side. So you want to end at one last number always. So you don't overflow the array or don't overflow the numbers. Okay? This is, or start at 1 and then end an n. So you have the previous number. I do this more often. I start at 1, but for now we're going to do this. And how do you check a sign of the number? You just check if it's positive. Now what happens if it's 0? A 0 is probably a positive number, I guess. Yes. So if a of I is a positive number and a of I plus 1 is also a positive number, then we can print them out. Don't forget new lines. also, and I always do continue because I can just copy the statement down and do this. If they're less than 0, printf. Now you don't need continue actually here. And this should work. Oh, now zeros are copied, so zeros don't matter. Okay, zeros don't matter. So if that's the case, we can just check. We can just check if a of I is equal to 0 or a of I plus 1 is equal to 0. So either way, we can just continue. Continue is just skipping this for cycle and going to the next. Very useful thing. It's recommended not to have multiple if statements one inside, but actually to get rid of this nesting. Okay, now it passes. Not sure about 0 here. Not sure about 0 because it's not really given good test. It's not given good samples, but I hope this works. It may not work because of 0, so I don't know. Oh, it's a compilation error. Okay, so apparently this compiler doesn't like this terminating character, which is fine. So apparently some compilers don't like that. My compiler likes it. So I don't know what's this. Expected declaration or statement at the end. Okay, doesn't matter. Compilation errors are not treated. Compilation errors do not have penalty most of the times. How do I submit now? Submit solution. See, 100,000. Now you see I can't. Okay, it gets accepted. Now without this termination, you can't really see what's the number. You need to count the zeros, which is a little bit. Bad, but it doesn't matter. Okay. Now we saw how to deal with the neighbors. Always deal with the neighbors with having one of the numbers, and then the other number is either +1 or -1, or maybe both. Here was an element. Here was a task where. There was a task that you need to find, for example, a common task is to find an element which is bigger than both of its neighbors, let's say. Then you do this. You do a of I is bigger than a of I plus 1 and a of I is bigger than a of I minus 1. And just be careful on the bounds. Be careful on the bounds. Okay, what shall we do next? Okay, do you have like an interesting, what is this inverter? Do you have an interesting problem that you might want to share? Give an end integer, print them in reverse order. This is very easy. Okay, one more thing maybe I want to show as a trick is something called frequency arrays or histograms. It's a much more interesting name. But what are frequency arrays? Frequency arrays are essentially. So let's do another. So frequency arrays. What are frequency arrays for the beginners? Okay. Frequency arrays. So do not write this. What is frequency array? Frequency array is an array where it stores how many times an element has been seen. So how many times we have seen 1, how many times we have seen 0, how many times we have seen 1, 2, 3, 4, and so on. And these are very useful. Maybe we can find some problem which require them. Frequency arrays. These are very useful for big problems, big inputs, maybe to compress them. So we only care, let's say, how many ones we have, how many twos we have, how many threes. This is not, I think it's not that maybe common in beginner problems, but it's very useful to know sometimes, to just maybe even in smaller numbers. If I say even in smaller quantities, if I say how many, let's assume we have this problem. Let's assume we have this problem. We are given n numbers, and we need to find the difference between the number which occurs the most times and the number which occurs the least times. Okay, so here is a very simple problem. We're given n numbers. We need to find the difference between the number which occurs the most and the number which occurs the least times. So how are we going to do this? Let me ask some of the beginners in chat how we are going to do this. Give me some ideas, because maybe let's solve this problem. The difference between the number which occurs the most times and the difference with and the number. So for an easier, let A be the number that occurs the most times, and let B be the number that occurs the least times. So what the answer is just A minus B. It doesn't matter the sign. It could be negative, it could be positive, it could be anything, right? So probably this somewhere exists, but we're not going. I mean, we can really quickly solve this because it's an interesting problem. And all of the numbers, so all of the numbers are less than 100. What do you mean two counters? Can you explain a little bit more? Because I want to hear your solutions actually to correct you, or to give a good, I mean, to congratulate you for a solution. Why not? All the numbers, let's say, are less than 100. So it's nothing. Two counters and then subtract them. I don't really know what twice the minimum sum of the largest. These are all very easy problems, though. Sum of positive and major. What is double reverse? Can you elaborate a little bit more on the solution, so, or maybe someone else has, even if if you're experienced already, then of course this stream is not for you. This stream is strictly for someone starting with arrays and integers and like in like competitive programming. This is the basics of competitive programming. You're thinking about a solution, how to solve this problem. I'm just reading this problem here. Alright, it's not. Visible sum pairs. So you don't have a solution, so we can solve this. Find and print the number of pairs. We can solve this problem as well. Okay, so the solution goes like this. You have an array. Because all of the numbers are less than 100, you only need an array of 100 to keep how many numbers, how many times a number has occurred. Okay. So I call this a frequency array, and I will do it 110. And even though I don't have test cases for this number, why do I do it 110? Because I want to have a lean room. If I make a mistake somehow, I don't want to go over the bounds, especially when I will put them all to zeros. So even if I go over the bounds, it won't really matter. Okay. That's why I just add 10 or something like that to the end of the array, of the maximum array that I'm thinking of. We're going to put them all zeros. So this is our problem we're solving. Okay, we're going to put them all zeros, and we have now the elements in some array here, right? Now what we want to do is iterate over the elements, and the frequency array at the position where this element is, we want to add on. Okay, we want to add on to the position where this element actually belongs. So I hope you understand this. The frequency array if this element is 1, if this element, let's say, is 3, then at the third element of the frequency array, I'm going to add +1, because I have seen 1, 3. Then what I'm going to do is I'm going to iterate over the array. I'm going to find the number with minimal occurrence and the number with maximal occurrence. Okay, so I'm going to I will have two counters, but not actually. What I need to have is I need to have a minimum, and this how is best to call it? This is a minimum, let's say, counter, and in minimum number, int max counter. The minimum counter, I will say it to int max, to something like 999, something like big, doesn't matter, or n+1, also doesn't matter. Let's set up some big number. And the minimum counter is going to tell us how many, what is the minimal number of occurrences that one number has. And if now we're talking about the frequency of that number, That's why we're not going to n actually, but we're going to 100, right? We want from 0 to 100. if the frequency of that number is smaller than the minimum counter, the minimum counter we update with that frequency, and the minimum number we set it to I, because this has the minimal number of occurrences. Now, also we check for the maximum number of occurrences. Now the maximum number from the beginning is 0, so max number, max counter, we're going to update the max counter. Always when you have like a condition like this which compares to some counter or some like best thing, you always want the first line or the last line, you always want to update that. And don't forget to write this, even if it's the last line, even if I want here to, like the last thing to update, just write it right here and then code here, because you could forget and you could debug for hours. Simple mistake, simple. And the max number is this, okay? So we found the number which has the minimum number of occurrences and the maximum number of occurrences. So I want to just print their differences. Max number minus min number. Okay? And this is the solution. Now let's create a test case. So how do we create a test case? Let's say we have 7 numbers. Let's have like this, like let's have 100, let's have 90, and then let's have many 90s and like 2 2's. So the best number is like this. So 90 is the most occurrent number, and then 2's is the least. So the result should be the difference between them. It's not, because is it 7? Yes, it's 7. Okay, let's debug this. I can't see with such big letters. The frequency array, the minimum is smaller than the minimum. The minimum is the frequency. This is bigger than the maximum. Max number minus. So here max number is satisfied. The min number is not. So let's print out this frequency array here. I mean, we need to print out here the frequency array. So we have, you see, you have 1, 1, you have 2 2's, and then you have 4 90s. Okay, so I already see the problem. The problem is that the minimum number of occurrences is 0. Okay, so you're doing minimum number of occurrences, but the frequency is 0. So you have to check if the frequency is not 0. Okay, and now, we said that is the minimum number of occurrences. You see, I was like wrong here. I mean, I wasn't wrong. I was only it's an 89. Why? Because this is the most number of occurrences, and then 1 is the least number of occurrences. Not 2 actually. Why then? What's wrong with me right now? Okay, it's 1 is the least number of occurrences. I mean, this works. This will work even like if you have test cases. Okay, give me some test case. Probably you have to check, like, if it's only one number, then it will work. The difference will be 0. I mean, if it's one number, difference will be 0, because this is the most occurrent and the least occurrent. Two numbers with equal appearance. Okay, this is correct actually, two numbers with equal appearance, but this is not satisfied in the statement. So with equal maximum or equal minimum appearance, the statement doesn't say anything about this. So the statement should in turn say that it is guaranteed. For example, it is guaranteed. I don't know how to spell guaranteed, but that's why Visual Studio Code has this spelling checker. It is guaranteed that two numbers do not have an equal. That's a good point. You see, you try to find edge cases where my program will fail, right? It is guaranteed two numbers do not have equal number of occurrence, appearance, whatever, occurrence, whatever. I don't know how to spell that. Okay. So these guarantees will be given in the statement most often, or will say that if that happens, take the bigger number. Okay, that could be the case too. Divisible sum pairs. You're given an array of integer a, so you're given some array, right, and a positive integer k. Find and print the number of pairs, so ij, where I is smaller than j. So I will tell you what that means. Where I is smaller than j, and the sum of this is divisible by k. Okay? But because we see that n and k go to 100, and even a of I go to 100, it's a really easy problem. It has a quadratic solution. Let's code it, because this happens a lot with arrays. I'm too lazy to code this again. So we have some array a, and now we see that n can go up to 100. If n can go up to 100, we only need 110. Something like that. Just put something a little bit more. Doesn't matter. Okay. Now we need to input k. Don't forget to input k. We also need to input k. Okay. And how do we solve this? If you see a problem where find and print the number of pairs ij such that I is smaller than j, you have to think about this. You have to first iterate over I, and then for every bigger number than I, for every j bigger than I, do this. Okay? So just a simple for loop from 0 to n, right? Where j is I plus 1 to n. And now if the sum of these is divisible, and don't forget having brackets because of priorities, if the sum of k is divisible by k, we want to have some counter. Or I will say, like, most of the time I just do NSA as a short for an answer. So NSA plus plus, and then print NSA. And it passes the sample. You see, it's a small, like, it's a very easy problem, but this is very important. For each I, you iterate first through the I, and then you go for that I, you see all of the j's which are bigger than I. You don't need to see anything less than I, right? Okay, and just count them and print the answer. Why pending? Okay, A plus. Okay, so let's find something even more difficult now. Now we're going this is still very easy, for anyone. Initial values of elements. Now, can you send me some problems which you think might require some more thinking, and I will solve them. Can you send some problems which you have practiced so I can solve them? And maybe we can find, what is this, digits? Find the number of digits. No. These are all classifications as easy problems or what? Beginner problems, beginners. Let's find something here. The first is not greater. Floats also, yeah. Maximum of absolute values. Interesting product. Twice the minimum. Which quota? Use the function. What is use the function? Alright, this is just an arbitrary functions. Shift the elements to the right. Common thing to do. Shifting all of the elements to the right. So, yeah, this is a very beginner-friendly problem. So you're given a linear array of n, shift its elements cyclically one position to the right. So the last element will actually become the first element, right? Okay. So you see the last element becomes the first element. Now you will think, wait, now I have to do if statements. I have to see if the last I first swap, or what do I do, right? But actually there is a very clever solution to this problem. It doesn't require if statements at all. We're going to do first an easier version of this problem, then a harder version of this problem. Just copy it. Okay, we're given n, and we have some array. A doesn't matter. I don't ever know how to name these arrays. I just do A because it's the first letter of the alphabet, and then I just do this. Okay. First of all, we are going to print the numbers only. Then we're going to for a harder version of this problem, we're going to put them in another array and then print them. That's going to be totally equal. So, do you have any idea how we can print them without using any if statement whatsoever? Yeah, you can have another array where you can put the elements as well. It doesn't matter, but I don't want to use if statements. Let's use only for loop. Only a for loop. How to do it? It's a clever idea, and the idea goes like this. You will use modular arithmetic. When I say modular arithmetic, you will say, well, what was that, right? No, it's nothing. we will use modulo, right? We're going to go over the elements, but what I want is, like, I want to print this element, start at this element, then do this, then this, then this, right? So I can actually map this element to the zero, to zeroth, okay? So how to do this? I will print them, but then we will just do this with another array. If I want this element to be 0, this 1, 2, 3, right? Then when I have here 0, I want to shift it 3 times. So this 0 shifts 3 times to here. So it's 0, 1, 2, 3, right? So what I want is x plus n minus 1. So because n is 4, minus 1 is going to be 3, right? I shift, let's see if you see this. I shift I with this number of times, right? But then I want to do modulo n. Because for 4, this will loop back. I will draw this, and then I'm just printing the a of this. This is going to be the index, and I'm just printing a of this index, right? Whatever, like, close this. How do I close this? Whatever, doesn't matter. And I need to put space in between. Then you see it prints, it passes the case, right? Okay, so how do you do this? You always want, it doesn't matter how many elements you shift to the right or to the left or whatever. You always want, this is the current element now, 0, right? Then I'm shifting the 0 to the right. So plus, I'm shifting this one to the right of, so if it's like 1, I want to be shifted. So how do I explain this? I shift, I see how, like, the 4, I want to come to here to 1, right? So I need to do the following. I need to add 3 because this is 0, 1, 2, 3. I need to add 3. Now let me so in this is the array, right? I hope you can see that. So this is the array, right? So in one iteration, when I add one number, these are the indices, 0, 1, 2, 3. When I add one number, the indices become 1, 2, 3, 4. But I know I will always be modulo n. What modulo n does is loops back. So the indices modulo n will become, this is 1, this is 2, this is 3, and now this is 4. This is 0. 4 modulo 4 is 0. Loop back. So here is going to be 0, 1, 2, 3. But that's not really what I want. I want to shift it 3 times because I want the 0th element, which is 1, to come to here. So okay, I'll do one more shift. Let's add one more thing here. 3, 4, 1. Let's modulo n. 2, 3, 0, 1. And you see 0 now becomes here. I need one more shift. But how to easily calculate this? How many shifts you need on the right? So to be so like this is shifting on the left. No, it's not on the left. It's on the maybe it will be better if I write this formula. So like maybe it will be better to understand this. If I want to shift one element to the, so it's like it's an opposite sign, because if I do I plus 1, it's taking the right element. Okay, so if I'm here, I take this element and I put it in this position here, right? I put the 3 in the position 2. But I want, so this is shifting to the left. So this here will be shifting to the right. I take this element and put it here, right? But because we can't do -1 with modulo, we must do plus n minus 1. So this is the same as writing I minus 1 plus n, because n modulo n is 0, because if you write like this, it could be a negative number. What if it's 0? Then it's -1. Then modulo n will be still, but I'm not sure about it. That's why you add plus n, and then you modulo to n. What modulo does is just, if it's a bigger number than n, it just loops back to 0. And that's it. It's a nice technique that you should remember how to use it. If you want to shift one element to the right, -1 plus n modulo n. If you want to shift to the left, do this. If you want to shift to the left, do it +1. You can do plus n as well, and modulo n. You can not only shift one by one, but you can shift by k or whatever. You can shift by whatever amount you want, really. Always check your solution that is actually correct. So you see how good is this solution. You see how like compact is this solution. You can use another array as well, right? You can use another array which will of course do exactly the same thing. You can copy this here and in another array and then print it, but you may be asked to not use more memory, and then you have to think about how to do it without more memory, so with one array only. Okay, maybe we went too far on this perimeter, the area of a triangle. I know that for many beginners, geometry will be like only perimeters, like, or you will be given already how to calculate, for example, the area of the triangle. You can calculate it with that formula, with the half perimeter minus a, but that you will be probably given the formulas, although their geometry is pretty cool, especially with like cross products and these things. Area of a pyramid. Maybe we want to go to some like more mathematical problems. So let's put for like beginners mathematics problems. There were only like some kind of a math competition. State test competition. Math problems from 6th to 8th grade. There was another only maths competition. Only math. I don't know where I went. Found just math contest, just math easy contest. But I don't know if that's what we want to do. Suppose that a certain number of rabbits are planted in cells. If the number of rabbits more than cells, at least one. Okay, this is the Dirichlet principle. In the problem, consider the more general case of the criterion. Alright, this is a very easy problem. This is just division. I know we should maybe do, should we do more implementational problems or should we do more math problems? Implementational problems like with arrays or with like some digits or something like, always you can convert any number, its digits, you can always put them in array and work there very like more easily work with like with arrays than with numbers. Also, one more trick that I already showed somebody, but I don't know if some other guys know. But another trick is that the power function. Remember this very well. In C or C++, I think C also has power function. Include math or something. Math header. Okay. You can see what it says. Double. It expects double and it returns double. So you will say, what's the problem there? Well, there is a problem. Doubles are inaccurate. And there could be cases where the power function returns a wrong value, especially with huge numbers. So, what I recommend when you have like low constraints, beginners will always have low constraints. If you need some number to the power, let's say I need 2 to the power of 8, right? 2 to the power of 8. I need this. I need power of 2 to the 8. Okay. I will do my own power function. Doesn't matter if it's int or long, it's better long, of course, but I will do my own power function. I will have a base and I will have an exponent. The result is f1 from this to the exponent. How many exponent? Result times the base. So I will do base times base times base exponent number of times, and I will return result. And I will print here this answer. For example, I need it somewhere. It doesn't matter, right? This is 256. 256 put to the power of 8. This is correct also 10 to the power of 8. Much more correct than using the built-in power functions. That's why I say always make your own functions. This is to the power of 8. This is 80, this 40 is 40. Make your own functions. These functions with doubles are really good for when the exponent or the base is floating numbers. It's a double if it's decimal or if it's a real number. But if it's an integer, just do your own power function, man. Like, it doesn't cost you anything. You write this in like what, 10 seconds, right? And you do this, it's way better. It doesn't have any errors. It doesn't have any, like, it happens that the doubles are inaccurate. Also, another thing which for beginners is Yeah, long longs. Use long longs when the numbers are huge. Also, when multiplying two numbers, the number can get huge. Another thing, when you have an integer, let's say you have some number and you have some other number, right? Now when you multiply these, I know that the result will be a long long. So okay, I will say result, but I just don't say a times b, because this will be wrong. I need to convert this. I mean, a is not the array. Let's the a things. I need to convert this first to long long, then multiply to b, because if one of the numbers is long long, the multiplication step will be long long. I think if the first number is long long, if the second, I'm not sure. But you always want to cast first, then multiply. Because if you don't cast, you will have an overflow. Another thing could be helpful. Ordering numbers. Let's see this. Oh. Well, for most beginners, you're gonna have more implementational problems. So this trick or any other, maybe like give me some kind of a problem in chat so we can solve it together. Other things which might be helpful. Okay, while cycles. Do while is fine. Yeah, it's fine, but rarely used. While true is also really good. Just do not forget to have a breaking statement inside. So while true is a forever loop, but like you process something. Let's say you process here something, and then if some condition is met, right, break. And don't forget this, because you will just crash the program many times. So don't rely on the debugging of the IDE. Rely more on the debugging of your own debugging. So printf is the most powerful debugging tool ever. Okay, let's see. Math problems. What is math problems? Are they going to be easy? Matrix multiplication, Fibonacci numbers. No, I mean, come on. Series of powers. There is also a binary explanation, but like you don't need this stuff for the beginner. 6th to 8th grade problems. But also these are. No, I don't want to read their statements. No. Not what we're looking for. Okay, implementational problems. Let's search for problems. Beginner implementational problems. So something like ad hoc. Ad hoc. Simple mathematics. Array, two-dimensional, linear. So beginners. Yeah, beginners are going. Increasing product of digits. Number of words. Okay, let's solve this. So you're given some string and you're asked to print out the number of words. Okay. So how do we do this? I want this from chat. I want this, like, I want chat to tell me how do you do this. Chat. So it says that the number of characters does not exceed 250, so let's have a character array. Let's call it A. 260. A. So let's scanf. What was the... Was it the string like this? Scanf? Let's just... I have no idea how it's this. Okay, so it scanf only one string. So this will be like even easier problem. What you want to do is you want to but what if one word is and A of 0 is not the null termination character. Let's see if this will work. Then I will explain this. I really have no idea how to get line in C. No, it doesn't work. You see, it. I don't know what scanf actually returns. Error while compiling. What's the error while compiling? Scanf. What does it return? Can I print? So there's nothing from the audience. I'm learning C. Oh, I just want to print it. Turns 11. Why 11? Is this 11? Seriously, how to read, how to get line in C? There is the getLine function. Okay, let's try it. I want to do getLine, then A, then size. I don't want size. What is the size? 260, let's say, and then std in. Then I need to import some library, whatever, std. What is this? Why is it working? Yeah, apparently. What's happening here? Oh, so you're reading with the while cycle. Okay, let's see. Okay, let's first just read like this and then print like this in order to see if everything works. Like it should read one character only. Okay, now I want to see what does this return. Okay, because I'm not sure. I think it returns 1. It returns 1. Okay, let's put it in a while cycle. Let's put it like this. So it always returns 1. Probably it returns, what does it return? Scanf return value. Returns a number of fields that were successfully converted. If it's 1, it will always be successfully converted unless it's something like, let's see. So it's sorry for my debugging, but scanf returns the number of fields. So it's probably, this is not like, it's not, because on this test case you're going to have multiple here failures. So we have to read it with a get line or something, as far as I know. I just want to see what it returns. Okay. Weird. Totally weird. Can we just do this? While scanf and then like do character and then do at counter plus plus. Then we want to print out this string here. Can we do this? No, apparently scanf returns int a of I counter -1 is not this. Okay, this works. uh, I have really no idea how to do this in C, but this works. So like what you're doing here is you're scanning each like character, you're reading a character, and you're putting it in this array, and then you are just incrementing a counter, and you're asking here if the last character, so counter -1, was not the null termination character. If it was the null termination character, it means that the string has terminated. Okay, and that's why now we have the full string. Okay, now when we have the full string, it's very easy to go over the string because we already have the counter. It's very easy just to go over the string. And now we need to count the words. Well, how do we count the words? We're going to count the words not by the words, but by spaces in between. As long as, like, do you have, like, let me see, it's guaranteed that the words does not contain dashes, hyphens, digits, and numbers. Alright, maybe we're gonna count them. Sometimes it's very easy to count them like with the number of spaces. So here are like 1 space, 2 space, and 3 spaces. So you know that there are 4 words. You can have space on the end. So even if you have space at the end, just print the number of spaces. But let's count the number of words. So the word. So what is a word? A word can contain lower case and uppercase English characters, right? So we have to check if that character is a lower or an uppercase English character. So the way we do this is we say if A of E is bigger than A, bigger or equal than A, and if it's smaller than or equal to Z, so this is one of the conditions, or A of E is bigger or equal to A, and A of I is smaller than Z. This is the other condition. So we know if it's this, we know that it's inside the word, right? So if that's the case, we want to increment a counter, right? And want to move as long as this is true. So we want to like answer, have like this an answer. Let's print it out. This condition, because it's already a condition that we need to check once more, what we're going to do is we're going to put it in a function. A bool function, and don't forget to include std bool. A bool function is character, for example. There could be an already done function, so I don't know, but I will just return this statement. Okay, I'll just return this statement, but now instead of this I will change them to C, to this character. So I'm returning, is this true or is this true? And now I can just check, is alphabet at I of I. If it is alphabet, we're going to get the answer plus, and while is alphabet A of I, we're going to increase I. And then at the end we're going to decrease I. Why? Because this loop will go through the, let's say we find this character, right? then this loop will increase I here, 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 and here. Here, we'll see that this is no longer an alphabet character, right? If it's no longer an alphabet character, it will break the loop. But now this I++ will still be will still be called, right? So we're going to go here, right? Which could be, yeah, could be okay. I was just like returning back, so it's like, but yeah, sure, this could be fine. Could be both ways could work. Now it passes the samples, and it should pass. This is also a common thing. So if you find something, while this is true, you just I++, I++, then you try to find another thing. Try to find another word. I'm not sure if it will work here because of the environment, but I think it should work. I'm not sure about this, like this termination signal. I'm just this might, yeah, okay. So it passes the samples. This is also a common technique. It's yeah, it's an easy problem. We may solve like one more just for the heck of it. Why not? The ratio of the product, the height, the sum of digits of two-digit number, the heights of a triangle. These all are very beginner-friendly problems. Majority element. What is this majority element? Given an array, find the majority element. The majority is the element that appears more than n divided by 2 times. So this problem can be solved. Can be solved with the frequency array. Now we don't know the elements, and positive integers are given. We don't know what's the upper and the lower bound of these integers, or are there negative numbers as well, or there could be like non-numbers that appear and divided by 2 times. That could be the case. I guess because this is a simple problem, I guess it can be solved without the data structure. Also, what you can do is you can have a naive mapping of elements. You can do this. You can have an array of elements which will tell you instead of what we've done with the frequency array, we could have a mapping array. But this is a little bit off topic today. This array allows us to map a specific element to another specific element. So how many, like, map, like, let's say 100,000 to 3. What this means that like 100,000 is 3 times present. But yeah, this is way off topic. That's way off today's alphabet graffiti. What was this problem? This sounds interesting. This sounds interesting. A form of graffiti barbaric. I'm just skipping here something like since the drawing has solid 2. Spelling English. Search others things. Oh, what's this? Like how many? Okay, whatever. This stupid problem. No one likes such. Lowest bit circle. What is circle of previous number? Next number. Maybe I have something from number of students. Opposite number of students. A boys and girls. How many students? What? School concert, perimeter and area. So there's somewhat very easy problems. I'm searching for a harder one. A bit. What is this? Beginner problems, logical articulation points. Okay, let's solve for maybe like the what about like solving the Fibonacci? Because it could be yeah, for beginners it could be very well. Math problems, Fibonacci numbers. Oh, this is the greatest common divisor between two. Let me search for the Fibonacci. Search for a problem. Search Fibonacci. Fibonacci numbers. Fibonacci sequence. What? All these problems? No, this is not it. Fine. This was what I was looking for. Okay, let's solve this as our last problem. Or if you have like some problems, please do tell me. Please. Okay, so Fibonacci numbers. How? Let's write this in code. STD. IM. So we're just reading in. And I'm going to explain everything about. So we need to find the nth Fibonacci number. Now this nth Fibonacci number is the Fibonacci. I'm seeing why it's not using this. The 10,000 Fibonacci number is really big. Why is not using modulo? Or it's fine. Is it fine? Because always these are calculated with the modulo. Okay, I will expect like if they didn't say that there's a modulo, I will expect that it's fine without modulo. Okay, so how do you calculate the nth Fibonacci number? You start from the base case. That is that Fibonacci number 1 and 2 are both ones. And then we can derive this formula is given that we want the last number and the number behind the last. Okay? So it is very simple for us to do. And we don't even need an array. Let's do this without an array. Okay? So let's do this. This is going to be the last number. And this is going to be the last number. Okay? Now we say if we need to say that if n is equal to 1 or n is equal to 2, we print, this is our base case, we print f1, right? And we return from the function. It's done. This is the best case. You do this, you don't do else here. And then like this. Because this will be one indentation plus. It's better to do this way. It's much more convenient. Okay. Now to get, we're going to start from the third Fibonacci number, where I print something in for loop and increment its counter, but I don't need the last counter to be printed. How can I remove it? Excellent question here. Excellent question. I will show you, I will answer this question, but first let's just program the Fibonacci numbers, and I will be back to you. Okay. Let's start from the ith Fibonacci number, and then we need to go through to the nth Fibonacci number, because that's what we want to calculate. There is a faster approach than doing all of the n numbers, but we're not going to cover this. This is way beyond this topic. Okay. Now the current number, I will say the current number, is this where I'm calculating it? Okay. Now the current number is the sum of these two numbers. Okay. And actually I will do them all long. I will make them all long. Now the current number is this. Now we have to shift these numbers. So the last number now becomes f last. Like it should become the current, right? But before it becomes the current, f last gets from the last. So it's shifted by 1, right? And when we calculate this to the nth, we just want to print at the end the last calculated number. Okay, because this is going to be the nth number. It passes, okay. This is how we shift Fibonacci numbers. And let's try here. Let's try this number. 1, 2, 3, 4, 5, 6, 7, 8. Let's try the 8th number. It's supposed to be 21. It is 21. Let's submit this and I will answer the question. Let's submit this. Here, very important, the way you shift. Okay, it's the wrong answer because it fails on these test cases because these numbers are too big. Okay, and I don't know what modulo are they using, but I will guess what modulo are they using. I will guess that. I will guess that it's this module. Wait, why does... No. Because it has to be... it has to be with a module, I just... Or maybe you're supposed to write it in a Python. I don't know. I will try with this module, but if that doesn't work, then... Because these numbers get extremely large. Yes. Okay, you're supposed to write it in a Python line, or you're supposed to actually print this huge number. But I'm not going to do this. I may want to just find a problem which doesn't require this because it's a waste of time if I write let's see, see who has the most submissions. Fibonacci. In Python, you can do it pretty quickly. Just Fibonacci. Alright, but this is up to a 10. Is this the third Fibonacci? 1, 1, 2, 3, 5. Is this 0, 1? I think this should. Let me just check. 3 should be 5. Yes. I don't know Russian, so probably. So no, it's wrong. So I don't know what this does that mean. Oh, so it's it's a prime. It's the prime number. Again, this is actually, yeah, this is actually cool. So you're asked to write the nth prime, a prime Fibonacci number. So we have like these prime number. We have these Fibonacci numbers, right? We calculate these Fibonacci numbers. What is n? Okay, we calculate this Fibonacci number, but the problem asks us for the nth prime Fibonacci number. So the nth prime Fibonacci number. So the first Fibonacci, 1 doesn't count probably, 2 counts. So if n is okay, so we go through these numbers, right? And we're going to count how many of them are primes. But let's just solve this problem, because I will get annoyed if I don't solve it. I will say, while this for cycle is true, I will count the prime numbers. Okay. So I have already one prime number, and this prime number, the last prime number, is 2. Okay, and then I will say long. I mean, counter has the prime number. Okay, is 2, and then if n is equal to the counter, printf the prime, or 2, we're going to print 2, and we're going to return. This is our base case. Now from 3 onwards, we calculate the current prime, we calculate the current Fibonacci, right? But we have to check if it's prime. So how do you check if it's prime? Let's create another function, is prime, and let's now this may fail on time, because I don't know how big is the nth, is the 10th prime number, but I don't think it will fail. I don't know, we'll see. If it's prime, so we're gonna say yes, it's prime number, and we're going to iterate from 2 to the square root of that number. So this is saying, like, we are going I plus I times I is smaller or equal to that number. If that number divides by I, okay, then it's definitely not prime. It's just going to return false. Return false. And then here we can return true. Okay. If we didn't find any divisor, then there isn't any divisor. Okay. So we say if is prime current. So if current is the prime number, if current is a prime, then we say counter plus plus if n is equal to the counter. So if we found out our number, we're going to print it out and going to return from the whole function. So we're going to return the whole program here, not only the for cycle, the whole program, right? If we didn't find, then let's go find some other number. Okay. So apparently 1 is here, 3 received output 3. Prime is 2, counter is 1, so 1 is 2. Is 2 prime though? I expected output 5. How are the prime numbers here given? So 3 is 5. So let's think about the Fibonacci sequence. It's 1, 1. Then it's 2, it's 3, it's 5, 8, 11, right? So we say that the third prime number is 5. So if this is the third prime number, this is the second prime number, and this is our first prime number. Alright, this should work. Alright, now I want only to test out here for 10. How big is that number gets? Oh, the 10th Fibonacci number is this big? Whoa. This is actually crazy. 10th prime Fibonacci number. Compilation error, unknown type name bool. What? Then we oh, it didn't include bool. Okay, let's, how do we, and I'm going to answer your question in a minute. Okay, passes. Okay, your question. For those who want to see the code, this is the code. Your question is, I have a problem where I print something in for loop and increment its counter, but I don't need the last counter to be printed. How can I remove this? Okay. Always before, like when you print something, it's printed. So there's no returning back. But when you don't print, when you need to know, you have to know a condition where if like let's say it's the last, then like don't print this, right? Or if it's not the last, print it. Now the problem is, how can you get this condition here? How to know if if in this cycle this is the last. So if you're working with some number with like digits, let's say, then try doing if n is smaller than 10, let's say, smaller or equal than 9. This will say that n has one digit, like one digit is left. Or you can try, I don't know exactly what is the code. Maybe it will be better if you send the code, let's say, and then we discuss it and make observations on how you did, what is good and what is bad in the code, and how to maybe improve this. Right? It would be nice. So really you need to find a condition in which you don't want to print. This is like if I is the last, or I is n-1, or I is n, something like that, some condition like that, which will tell you that you don't want to print anymore. Yeah, do like return from a function if you are finished somehow. If you see that somewhere you're finished with the whole program with int main, just do return. Don't break out from cycles, but then like try test out just do return 0. Also very common is to have some booleans where you are you have like, is it okay? It's, let's say it's true, then here let's say it's okay, it's false, and then here you check if it's okay. This is also very common to have on beginner problems, as well as on difficult problems. It's common to check how what else can I show? Well, as you saw, beginner problems are solved really quickly. There's nothing. It's a problem cannot be so much complicated. Maybe the biggest beginner mistake is thinking that the problem is much more complicated than actually it is. Okay, this every beginner does it, including me. Including when I solve like harder problems, I think that the problem is actually much more harder than I'm used to, and then I see a solution which is like really small and elegant, right? But you don't always have the time to search for like elegant solutions. You much prefer to find some solution as quickly as possible. But even if you want to find some solution as quickly as possible, don't just go to the most complicated solution ever you can think, right? Also, when you're working with digits, now I remember, when you're working with digits, if you want to reverse the digits, use my trick with powers. Divide the number 10 to the power of I. Okay, so I'm dividing that number to some huge power. Okay, but I'm writing this power function, not this double function that uses doubles. Don't do that. N-digit numbers. N-digit numbers. N doesn't exceed. Find the quantity of n-digit numbers which the sum is equal to their product. Call the least from numbers. is not exceeding the n digit numbers, which sum is equal. What is this? I don't understand what's the statement here. What's this one? Whatever. Will you send me the code maybe so I can wait? Or maybe send some other problem as well. We may have like let's put it to 2 hours and 30 minutes. So mirror primes. This is kind of a cool problem, but it involves Eratosthenes sieve to solve it, unfortunately. Match model. I'm not gonna even try to explain this. So okay, if you don't have any other questions or any other problems, we might close this stream because we've covered digits, we've covered arrays, we've covered what to do and what not to do. Let's just go over the problems one more time. So Fibonacci numbers, you just shift the numbers. This is very important, shifting the numbers. Number of words, you find a letter, and then while it's an alphabet, you shift I to the right. And then while you don't want, you find like a space or something. Then find the word again. It's very easy. Shift the elements to the right. This technique with devising this modulo n. Then finding the pairs which are divisible by k, the number of pairs. And then frequency array, how many numbers of some number are like the occurrences, count the occurrences of numbers. Neighbors of the same sign, so check if they're 0, check if the next element is the same sign, if both are positive, both are negative, bring them. 2 digits. 2 digits in a row. So that was one of the digit. The last digit is 7. The digit before that is 3. If you find this, answer is true, break. And if you find the answer, print yes. Otherwise, print no. Then square of maximum. So this is getting all of the digits into some array, then sorting this array because we want to find the biggest number, so sorting this array, and then reconstructing that number again. So reconstructing that number. This is the way to do it. So go through the array. If the digit is not -1, then we want to shift what we have, shift it by 1 to the left. So this adds, is like if you have 13, then this will go 130 because it will shift, and this 0 we now want to add up this digit at I. So if digit at I is 4, let's say 134, then you shift again then you have this number. Now you add here, right? But we're going to add the biggest digit, then let's say like this, right? And print the result times itself. This has been it. I mean, it's nice to solve these like beginner problems. They always get accepted. Yeah. If you have any questions, please feel free to throw them now, because it's been 2 hours and 25 minutes. I hope you enjoyed the stream. Maybe, yeah, also swapping this thing here. Just have that in mind here. Don't use functions which are already I think, like, yeah, sure, use functions, but if you can do that, you don't have to use. Okay, thanks for watching. Then I'll see you on the next stream, which is probably going to be with much more harder problems than these, because these are very it's hard to explain beginner problems. You don't know really what to focus on. Thanks for watching, guys.